Okay, let's start. Okay, so we have the points A and B, they lie on the curve. So let's draw an image to represent the curve itself. Okay, so this is quadratic. Somehow we can tell that the coefficient of x squared is positive. We are able to fairly draw a fairly accurate diagram. Okay, and then we have A that is 1D and B is 5E. So let's maybe take A here and B maybe here. Okay. Then tangent at P is parallel to AB. Okay. So there is another point P that is on the curve, such that our tangent that we draw, okay, maybe let's do this first. Okay. The tangent that we draw will have to be parallel to the line AB. So that means that my tangent will have to look something like that, and likely this is going to be P. Okay. So because they are parallel, it means that the gradient will have to be equal. Okay. So what we will first do is take into consideration the equation of the curve, find out what is dy over dx. That will give us the generic gradient, okay, of all the tangents. Okay, but the specific one that is at P will have to be equal to the gradient at AB. So gradient at AB, okay, not say at AB but of AB, will have to be using our formula y2 minus y1 over x2 minus x1. Okay, so we have d minus e, 1 minus 5, that is actually negative 4. But then we realize that d and e are not values, okay, and it will cause a problem for us, okay, when we have too many unknowns. So how do we find out what is d and e? We know that a and b are on the curve, okay, so therefore the points 1D will have to satisfy the equation of the curve. Likewise, the point 5E will also have to satisfy. That means that when your x coordinate is 1, okay, using the equation of the curve, we will find 1 minus 5 is negative 4, negative 10. Okay, so therefore, A has the coordinates 1, negative 10. Then, we do the same for B. 5 squared minus 5, 6, that is negative 6. So our coordinates of B will be 5, negative 6. Then we can find out the exact gradient value of AB. That will actually be D is negative 10. Negative 10 plus 6, negative 4. Okay, so answer is 1. So the gradient of AB will actually be equals to 1. So because AB and our tangent are parallel, that means that our 2x minus 5 is equals to 1. And we can solve the equation by equating the two gradients, and we get x equals to 3. Okay, then our y will be 3 squared minus 5, 3 minus 6. That will give us negative 12. Okay, because our p will have to satisfy the equation of the curve as well, that's why we take x equals to 3, put it inside the curve, then we get negative 12. So P has the coordinates 3, negative 12. Okay, for part 2, to find the equation of the normal to the curve at P, line that is perpendicular to the tangent at P itself. So because they are perpendicular, your gradient of the normal will be negative 1 divide the gradient of the tangent, which is actually 1. Okay? So that is the gradient of the normal. Then to find the equation, that will be y equals to mx plus c. Since we're looking for the normal at P, we use the coordinates of P. So c equals to negative 9, therefore answer will be minus x minus 9. Okay. For part 3, it says that the normal meets the curve again at the point Q. That means you draw your curve or your normal long enough such that it touches the curve. So I can extend my curve here. So we're looking for this point here, which is Q. Okay. So it is an intersection point, and therefore we use simultaneous equation solving. Since I know the equation of the normal already, and I also know the equation of the curve. Solutions to x, that's 3 or 1, but we cannot have x equals to 3 because when x equals to 3 it is already P. So we reject x equals to 3 and find the y value when x equals to 1, that is equals to negative 10. So Q has the coordinates 1, negative 10. Okay. Regine, I hope that you're not just copying. Please understand, and then your homework is going to be submitted to me. Green, is it? Okay. Go back to try again now. Okay. Okay, next question 10. Okay, I think question 10, the other day one of your classmates was asking me how to do part 2. Okay, maybe I'll just quickly run through part 1 first. We have a curve. Question wants us to find the gradient of the normal. Okay, to the curve, to find the gradient of a normal, there must be a point. Okay, so this point is where the curve intersects with the y-axis. Okay, So that means that I need to first find out what is the coordinate of this point, especially the x-coordinate, because if without the x-coordinate, there's no way for me to know what is the gradient, because I know that when I differentiate, everything will be in x. I must know the x value to substitute, right? So, if we first do our differentiation, this is what we will get. Okay, intersection with the y-axis, that means that x equals to 0, y equals to 2. Okay, all these will be 0 values. Okay, so actually when the curve intersects with the y-axis, okay, actually, do I even need the y value? I don't need, right? Yeah, okay, now anyway, we find the point now, okay, the coordinates of the point. Maybe they don't need it. Okay, so then at the point 0, 2, our gradient of tangent will be our dy over dx. That is -4. Okay, but gradient of normal will be -1 divided by -4, so there is 1/4. Okay, so let's look at part 2. Find the angle this normal to the curve mixed with the x-axis. What does it mean? Okay, so I'm not going to care about the curve because our focus is on the normal itself. Our gradient of the normal is 1/4. That is a positive gradient value, so our line is upward sloping. I don't know how my line looks like, okay, but maybe let's estimate it to be like that. Okay. Now, what does it mean by the angle, okay, to the norm? Sorry, let me rephrase this. Normal to the curve mixed with the x-axis. Let me write down the question. Okay, so this is the exact words of the question. We're looking at the normal. Normal is a line, okay, meet with the x-axis. That means that we're trying to find out the normal and the x-axis. What is this angle here? That's what the question is asking. Okay, I intentionally chose this question for us to recall some of the things we learned last year. Okay, so like I mentioned, I'm trying to build certain things over here. Okay, otherwise when we go into revision next semester, I don't want everything to be like a very jarring thing for us. Okay. So how to actually figure this out? Last year itself, we know this formula, gradient equals to tangent theta. Okay. I think this will probably be at the way back at your mind now, okay? Maybe you don't recall this at all. But let me explain to you why is it that gradient of a line is equals to tangent theta. It is a very logical thing, okay? The thing is that this is a right angle triangle that we can see, okay? So I can form a right angle triangle here like that. We know that our gradient is rise over run. Rise over run. Okay, which is your y values over x values, right? Right angle triangle, this is the angle I want to find. In a right angle triangle using my Tuakaso, I know this is also opposite. This is also adjacent. Right or not? Okay? So opposite over adjacent, rise over run, they actually refer to the same thing in the same triangle. That's why we say gradient is equals to tangent theta. You understand? Okay? So it's a logical explanation, Right? So therefore, okay, now I already know the gradient is 1/4. So 1/4 equals to tangent tangent theta. Okay? Then after that, theta will be tangent inverse of 1/4. Key that into our calculator, we get 14.036 degrees. For angles in degrees, we leave it to 1 decimal place, so 14.0 degrees. Okay? Okay? Questions? Ellipsis needs to go and Reggie needs to go. Reggie, you better go and watch the video, huh? Okay? And then of course ellipsis you also have to watch the video. Is there a competition today? Oh, the homework how you submit today? Actually the homework end up is I do one, right? Or you got the console. Okay, you go back watch the video. Okay, then after that, Friday, ask it to weekend. Okay. So today is finals, is it, for volleyball girls? Not finals, then you all go for what? Oh yeah, you all start nationals already. Oh yeah, I forgot about that, sorry. I still kept thinking that you all still going to play against Hong Sec. Okay. Sorry, a bit behind time. Okay, so question 10 part 2 is there. Any questions? Okay, then let's look at question 11, yeah? Okay, next look at question 11. It says that a point P lies on the curve. It is again a quadratic curve and it is a set phase 1 because coefficient of x2 is negative. The normal to the curve at P is perpendicular to a certain line. This line itself may not be found on the curve, may not intersect as well. Okay, but just from this line, if I were to manipulate it, I will find that y refers to 3x plus 5, which is upward sloping. Okay, so let me just draw a random line here. Okay, this normal is perpendicular to this line. So the normal, okay, may be like that. Okay, so our normal takes reference from the tangent itself. So if I were to draw a tangent to this point where the normal intersects with the curve, okay, there is this perpendicularity. So this is the tangent, this is the normal. In fact, another way of interpretation of this question is that the tangent at the point P is parallel to the line that's given. Correct? Because if this is perpendicular to this, this must be parallel to this, since they have to be perpendicular. Okay? So, it is all happening at a point P. Okay, that we need to go and find out. Okay, so let's first do our differentiation. So your dy over dx is negative 2x plus 3. Okay, we already manipulated the gradient, or rather the equation of that straight line already. And we agreed earlier on that this straight line is parallel to the tangent. This is the gradient of the tangent. wait equals to, okay, yes, correct. Okay, so then we solve this question. So we find x equals to 0. X equals to 0 is for the point that is found on the curve. So when x equals to 0, your y coordinate will have to be equals to -9. Therefore, the point P will have the coordinate 0, -9, and that's how we show it. Okay? Questions? Next, part 2. Find the equation of the normal to the curve at P. We know the gradient of tangent at P is equals to 3 already. So gradient of normal will be equals to -1/3. So the equation of the normal will be y equals to mx plus c. And using the point P, we find that the equation of the line of the normal, will be y equals to -1/3 x minus 9. Okay, and then for part 3, we want to find the coordinates at point Q, where the tangent to the curve at Q is parallel to the normal in part 2. That's a lot to think about. Okay, so how do we interpret part 3 itself, right? We want to find the coordinates of Q where the tangent at a certain point Q on the curve itself is parallel to this normal here. Okay, so we draw a parallel line. The only way actually be somewhere here. Okay, and this will actually be Q itself. So this is how we could actually visualize what the question is trying to ask. Okay, so in order for us to find out that point there, okay, we know the gradient of the normal already. Use a different color. The gradient of the normal is -1/3. That means that the gradient of the tangent at Q will also be -1/3 because they are parallel. The gradient of the tangent at Q, okay, will have to satisfy the dy over dx because dy over dx is the gradient of the tangent. So we get -2x plus 3 equals to -1/3. Okay, and then we will solve. We'll find that the x coordinate will be 1 and 2/3. Okay, so that will allow us to find the y coordinate on the curve. So substitute it back into the equation of the curve. Yeah. Oh my god. Okay, so we get this. Right? May I know what's the issue for question 13? What's the issue for question 13? Huh? Part 3. Part 2 and part 3. Okay, then I'll jump straight into part 2 and 3, okay? Gradient or the coordinates of the point A, okay, and you have already done your dy over dx, which is 2x plus 7. Okay, part 2 wants us to find the coordinates of C. Okay, so we know that the question specified that the normal to the curve at A cuts point C. That means this line of the triangle will have to be the normal. Okay, so this has to be the normal, which is the perpendicular to the tangent over here. Okay, so since we know the coordinates of A already, and I know dy over dx, okay, so I can find out the gradient of the normal, which is equals to -1/5. Because earlier on in part I, you would have found the gradient of the tangent, which is BD itself, that is 5. Okay? So with the gradient of the normal and the fact that I have the coordinates of A, I can figure out the equation of the line AC. That would be y minus y equals to -1/5x plus c. So we find that c is actually 5/4/5. 5. So equation of the normal is y equals this. To find the coordinates of C that lies on the x-axis, so y equals to 0. And x equals to 29. Therefore, C is 29, 0. Okay. To find the area of the triangle, part 3, please make use of your shoelace method. Okay. So that you recall what is your shoelace method. I already know what is the coordinates of A, coordinates of B, as well as coordinates of C, that is 29, 0. Using my shoelace method, I have to do it anti-clockwise manner. So remember the half, negative 1/6, negative 2.20, 29, 0, and going back to the start. Okay? Then, this times this, this times this, this times this. Then minus away the other direction. And use your calculator to help you. Okay, this will be the values that you get. You should get 93.6 units squared. Okay, using your shoelace method, do not have to give me our performance. Okay, but then using your shoelace method will actually be much more effective rather than you go and find out all the length of line segments, number of units and all that. Although this question is not that difficult to look at the number of units also. Yeah, I think this question also not that difficult to look at number of units. Half times BC times your height. That will be half times 2.2 plus 29 times your height, that will be 6 units. Okay, you can count number of units as well. Right, that will be fine also. Okay. Okay, if you're done, can you please pass your homework down to the front?